Second question is a vectors question, forces and such things. We've got three forces acting on it and we're given an acceleration, so we can just use F equals ma. But F in here means resultant force, that means sum of the forces. So we've got three forces here. So minus 10I plus AJ plus BI minus 5J, there's that one there, plus 2AI plus 7J. Let's make sure I do a bit of squiggling of them, is equal to mass times acceleration. So that's 3 times, because it's 3 kilograms, 3I plus 4J. If I collect the I's and J's together, I get minus 10 plus B, for that one, plus 2A, for that one, equals to 9. Okay, well no, I. That's just collecting the I component together. That one plus that one plus that one must be equal to 9. Then looking at the J component, I'm going to have A minus 5 plus 7 equals to 3 times 4, which is 12. So that gives me A equals 10. And now I can go back to this one here, because A is 10, I have minus 10 plus B plus 20 equals to 9. So that gives me B equals minus 1. So that's it, nice easy 5 marks for us there. Okay, part B. At time t equals 0, the speed is u, and at time t equals 4, the speed of the velocity of p is 20I plus 20j. But if we refer back to the original question, we can see we've got three forces here, and it's got a constant acceleration. It's implied in the question. So we can use an appropriate equation of motion, v equals u plus at. And we're given the speed after 4 seconds here. So that's 20I plus 20j equals to u, which is what we're asked to find out, plus 4 times by the acceleration, 3I plus 4j. So that gives us u, when we work that out, because this is 12I and 20I, so that's 8I. And here we've got 20 minus 16 plus 4j. That's the initial velocity, but it wants the value of u, that's the velocity. Let's squiggle it to make it clear it's a velocity vector there. So we want the speed, which is the magnitude of the velocity. And we can just do Pythagoras on that, 8 squared plus 4 squared. Okay, so that's 64 plus 16, square root of 80. And that breaks down to 8.94 to 3 significant figures, or I think you were allowed to give it as an exact surd as well. Okay, and that's question 2 done. Let's look at question 3. Okay, so question 3 is a question with a uniform rod. It's the first thing I look for with these moments questions. It's uniform. And it tells us all the distances apart from the position of this support D. It tells us some important things actually. It tells us also, obviously, the weight of the thing, which is 12 G, 12 times 9.8. And it says also that there's a mass at B, which is 3 kilograms, making the weight 3G. Now it says, here's the thing to really interpret. The magnitude of force exerted on the plank by the support at D is twice that support at C. So the magnitude at D is double. If we call that 2R and that R, we'll get the correct ratio of the forces there. So that's going to be quite easy to work out because we're going to resolve vertically. The easiest thing, often the easiest thing to do in these questions is to work out whatever forces you can by just resolving vertically. Now upwards we're going to have R plus 2R is equal to 12G plus 3G. So that gives us 3R equals 15G. So R equals 5G. Right, now you're going to make life difficult for yourself if you don't use that particular. There's a couple of marks in the mark scheme attached to doing just that. Now it's a case of taking a moments equation. Now it's not, you could take about any of the supports here. It's the natural thing to do really because it takes out a force. You could take moments about C, for example, and if you took moments about C, you'd be getting something like this, 12G times this distance, which because it's 8 meters long, that'd be 12G times 1, and then plus this 2R times this distance here, which is equal to x minus 3. It's not plus, it'd be equal to that. And then we've got the moments of this force, let's move that across, plus 3G times by that 3G is going to be 5 meters away. So that's because both of these forces here are going clockwise about C. And then that equals to the moment of this force, which is 2R times x minus 3. Okay, and you'll get, it'll come out from that. But just to be different, just to make a point, I'm going to take moments about A. It doesn't have to be about support. So moments about A, just this will get you the answer if you want it, but just to show the point, you can take moments about where you like, but you know, obviously correct an appropriate equation, we wouldn't want to take moments about there, it would be silly, but or even further along the rod, that would be wouldn't make sense. But moments about A, it has a disadvantage of having 4 forces in it, but at least we've got x directly in the equation, so we'd have R times 3, that's going anti-clockwise, plus 2R times x, that's also going anti-clockwise, is equal to this one going clockwise, so that's 12G times 4, plus this one going clockwise, which is 3G times 8. So we know that R is 5G, so this is 15G here, plus 10GX here is equal to 48G plus 24G. Now G cancels from everything. That will give us 10x equals 57. So x equals 5.7 meters. Okay, The reason why I chose moments about A, it doesn't really matter, is that it just, the equation looked nice without any kind of bracketed bits like this, but it doesn't really matter. It'll also come out from moments about D, or even moments about B would work fine as well. Any one of those would be appropriate. Okay, let's go on to question 4.